Hi, everyone. My name is Tanya Hertz, and I'm the director of the Regional Entrepreneurship Center, the Rec Innovation Lab at San Diego Miramar College. And I'd like to thank our partners at this time and give a special thanks to SDSU's Lavin Center, the SDSU Zip Launchpad. We'd like to thank the California Entrepreneurship Educators Conference. Also like to thank Harness, the Brink SBDC at USD, San Diego Unified Schools. We'd also like to thank the School of Entrepreneurship and Technology, High Tech High, the Regional Advisory Committee, Alex Waters at the Jacobs Center, Connect All, 21IQ Labs, Startup Quest, Productified. I'd like to thank Course Key and Tech Coast Angels. Thank you to Village Up, City Heights Development Corporation, San Diego Angel Conference, Startup San Diego, SBDC, Score San Diego, We Are Kingdom, New Media Rights, San Diego Tech Hub, Origin 63, Ambrosio 15, OmniSync, Optima Office, Proven Recruiting, Craft Leadership, GS&L Consulting. Thank you to all of our partners. We couldn't do what we do without you. Thank you. I appreciate everybody being here. Welcome, everybody. Thank you for joining us here at the Rec Innovation Lab at San Diego Miramar College. We are really excited today to have one of our student founders giving a presentation, and we're particularly excited because there's been so many good things happening for this student founder. Brett has just been one accolade after another, and I'm not going to steal his thunder and give it away, but I'll let him tell you a little bit about it. We have a few more people coming in, and they'll be cycling in, but we'll go ahead and get started here in just a moment. So Brett, would you mind sharing your screen if you're ready to do so, and then I'll pass it over to Stephen. If did you have anything that you needed to add?
Oh, no, I think you covered Brett extremely well. I think we'll let him give the good news.
Right, let him give the good news. And if anybody has any questions, make sure while we're watching this, please do put the questions in the chat. Or if you would like to just ask the questions immediately, make sure that you unmute yourself, because the default is everyone is muted to limit that bandwidth. So, all right, Brett, you ready to tell everybody a little bit about yourself?
Yeah, so I'm Brett. I've been a student founder here for about a year now, and I just finished my last year of high school. Obviously, like, it was kind of rough during a pandemic year where we couldn't do a lot of like our senior traditions and such, but I did manage to get some good news. So we did place as honorable mentions in the Cooper Hewitt like National High School Design Competition, which was pretty big for our team. And I recently got some more good news where next fall I will be attending Harvard University, and I'll be studying computer science and economics. So I'm incredibly excited to move on to that part of my journey. And I just want to thank Tanya and the entire rec team for just helping me along my entrepreneurial journey. And I know because of this program, I'll definitely continue it.
I'm so proud of you, Brett. I love that. It just makes me so happy every time I hear you say it. So thanks for sharing with everyone, and congratulations on all the good news. So yeah, thanks, Brett. All right, whenever you're ready, you're welcome to get started. We can see your screen just fine, and you can take it away when you're ready.
Absolutely. And if anybody wants to add me on LinkedIn, they can add me right here.
Thank you.
And I will keep in touch with you all. Yeah, so just give a second for that. Okay, let's get into the presentation. Hello, everyone. So today I'm going to give a quick bite-sized introduction to like object-oriented programming and the world of programming as a whole today. I've had hundreds of hours experience teaching kids how to code, and actually adults too. I've taught kids from ages 6 to adults who are age 60. And I was one of those kids who used to like pick up books on computer science, read it front to back. And I remember one distinctive book was called like How to Learn XYZ Language the Hard Way. And after learning code like that, I can firmly say that it doesn't need to be that difficult. So learning programming for the first time often starts with a quick mental check. So everybody right now, I want you to consider what your obstacles are to learning code, because to be honest, the best learners I've ever seen weren't necessarily the most like adept with computers, but they started off like really early, accepting that anyone can code, themselves included. And despite how confusing or even esoteric learning code could get, the reality is that programming is a skill that anyone could build. It's just like learning your times tables for the first time, or spelling or reading. And I wanted to help create this course to just help get some of my fellow entrepreneurs more into code.
I think I didn't mean to interrupt there, Brett. I just wanted to say one little thing. Thank you for doing this. And it just aligns so well with what you do in your startup, teaching people to code. And I agree with you. And I think this is going to be really wonderful for all of us. So thanks.
Thank you. And yeah, and going off of what Tanya said, we're going to cover a good deal of information from the beta. Our beta only covers a small portion of the AP Computer Science A exam, which is like the biggest standardized exam for computer science in high school. So yeah, we'll be covering a good deal of that today, about like 2 to 3 weeks worth of content, or even more. But we'll try to take it slow. So as entrepreneurs, I believe that you're also signing up to be computer scientists too, to some degree. Chances are most of you have worked with a website builder before. And while that's not necessarily a code solution, it's a no-code solution, having a base understanding of web development can truly help your development of your site. And chances are, as you continue to build your successful businesses, you will work with a programmer at some point. And being able to speak their language is a huge help for communication, so your expectations and instructions to the programmer can be as precise and efficient as possible. And you might be asking, how is this course made specifically for entrepreneurs? So I know it says object-oriented programming on the title, but I've made sure to add a lot of content to this that also covers relevant information to you, the entrepreneur. This includes learning a bit more about like the industry of code, and hopefully will help you in your later like hiring processes as well. And this workshop will also include industry relevant jargon, and hopefully teach you how to communicate with your programmers a little bit better. And hopefully after today, everyone here will have a broader understanding of the fascinating world of code. So first, I'd like to break down programming, which is like very complex, because when you think about programming, there's obviously so many different ways it could go, from like doing something with machine learning to like systems operations code to just building a website. And of course, the world of programming is much more complex than I'm going to present on today. But as entrepreneurs, these categories of programming languages will be especially relevant to you. So let's get started with web development. The structure of a website is actually not done with a programming language, but with HTML, a hypertext markup language. HTML is the structure behind 92% of all websites on the internet. And if you've ever used websites like Google, Facebook, or LinkedIn, they all use HTML to put the content you see on the page. But without CSS, these sites would look nothing more than like a few people just typing something into Microsoft Word with no extra formatting. CSS stands for Cascading Style Sheets, and it is a style sheet language. This means that it helps format the layout of web pages that are created by markup languages. So if you want to go off of like a sort of like a Microsoft Suite analogy, you could think of HTML like a plain text notepad file. You could put like the content on the page. You could even like adjust where it is sometimes, but it doesn't really give you a lot of possibilities for formatting. CSS is kind of like Microsoft Word. It's much more ubiquitous than HTML, as it can be used with other popular markup languages like XML. And CSS is actually used by 96% of websites, so it's absolutely crucial to styling and positioning elements created by HTML. Almost every like design element you see on a website that's not like an animation is typically done with CSS, and with the introduction of CSS3, a lot of animations are actually becoming CSS based as well. Now, I'm going to briefly pause and go over front-end development versus back-end development. So front-end, and you might see that like on the slide over here, like JavaScript, Python, backend, front end. So front end development, just as a refresher for people who already know, is what the client sees visually. It's the Microsoft Word of the page. It's the looks and the content. And both HTML and CSS are exclusively front-end languages. But what distinguishes a website from just a pretty Word document? So in comes JavaScript, which is the last of the big three of front-end languages. JavaScript is used by 94% of websites on the internet, which actually puts it slightly ahead of HTML and behind CSS. At its most basic use, JavaScript helps users interact with web pages. For example, if you've ever clicked on an image and it zooms into it on a website, that was caused by JavaScript. When you visit a website and you see the image, when you see images on a sliding carousel going by, like, when you see like this image, and then like it has like an animation, and then it has this image, JavaScript is behind that too. And when you submit information into a form on a website, even like signing up with Eventbrite today to go to this event, JavaScript helps collect that data and send it to the backend, which I will explain in a second. But before I do that, I want to go on a quick tangent and mention that JavaScript is used for a lot more than just user interaction on a website. JavaScript is one of the most common languages for web applications as well. Frameworks, or a prepackaged set of solutions to common development problems, help developers launch countless web application solutions per year. And you don't have to remember these, but some popular JavaScript frameworks include Node.js, React Native, Angular, and Vue. I know that everyone here has used LinkedIn before, and LinkedIn actually runs on one of the JavaScript packages I just mentioned, Node.js. And Node is one of those flexible frameworks that can actually work on the backend as well. So what is a backend language? If you look on the slide, you can see that Python is one. Well, for one, the user never actually comes into contact with the backend. The front end interfaces with the user. It gives the user their experience. The backend helps fulfill the requests that are created by a user. In programming, data is pretty much king, and backend languages frequently communicate to databases holding user information. It's how login systems work and how social media posts get stored. Often, entrepreneurs themselves will not be coding or having much input on the backend themselves, mostly electing to hire a developer to handle those needs for them. And this is frequently due to the amount of time it takes to manage the backend, even if they have experience with it. And you want someone to really meticulously code your backend for you because of the security and complexity reasons. As you can guess, backend developers are much more in demand and difficult to get. So if you find a good backend developer for your company, my advice is try to get them to stick with you for life. It's one less thing to worry about for your website or application. However, startups will frequently recruit something else called a full stack developer, or someone who can cover both front end and back end development. While they're not necessarily specialists in either side, they could lay down a quick MVP, or minimal viable product, all by themselves, which often is all a startup needs to get going. And now that I've rambled on about what backend developers do, here's a quick guide to the most popular backend languages. Some JavaScript frameworks like Node.js, as previously mentioned, serve as backend languages as well. JavaScript is fantastic for working with data, and it is highly cost efficient. And part of the reason why it's highly cost efficient is because you get to work on it on the front end, and then you get to work on it on the back end. So you can hire one developer to cover both of that typically. Python, the language my startup, Oiku Tech, teaches, is one of the easiest backend languages to learn. Its main advantages are its simplicity to learn, it's chock full of fantastic libraries, And libraries are pretty much like packages of code that can be used for other purposes. And some of these libraries include machine learning and more. However, Python's processing time is relatively slow compared to other languages, and it is highly dependent on these aforementioned libraries. These libraries are mostly secure, but if you happen to like stretch really far and use like perhaps a library that support drops for it, that could be a possible risk. And there are other backend languages like Ruby, PHP, and you've probably heard of this one, Java. But for now, we'll just keep them in the same category as popular backend languages. PHP, for one, used to rule the backend world, but they've been slowly losing market share to other, more modern languages. And I'd like to briefly add that while mobile development frequently requires different languages, they share quite a bit of similarities with web backend languages as well. While many entrepreneurs understand the front end pretty well, after playing around with website editors or other no-code solutions, I've frequently found little fluency into the backend as well. Now you might be thinking that I just said that entrepreneurs won't be involved in the coding or design choices of the backend very often. So why should you need to learn the backend? And one of the most common reasons why development slows down on a team, especially in software teams, is a lack of communication between the entrepreneur, the idea maker, and their development team, the people who get it done. Often this communication comes from a lack of understanding an entrepreneur has for the inner mechanisms behind their product. And I'm not asking everyone to start enrolling in Lambda school because, like I said earlier, most entrepreneurs won't be involved in coding their own product in the first place. What I do propose is a quick run through of some core programming concepts that will help you better understand the coding process as a whole. When you stumble upon articles discussing programming, it'll become a lot more accessible to you, and you'll be able to more effectively communicate with your programming team and get more things done. I do a lot of freelance volunteering where I help program websites for nonprofits, and the difference between development time, where the manager of the product even has a little bit of program experience, versus none is huge. It sometimes saves me 10, 20 hours because often it helps them make more precise decisions on what they want from me, and it speeds up development time tenfold. For an entrepreneur, that means your product gets out there faster and you make your programmer's job a hell of a lot easier. So let's get into it. So I'm going to briefly actually pause and ask if anybody has a question right now, because I know I just covered a lot of information.
So I don't see any questions in the chat. Does anybody have any questions that they'd like to ask right now? I think just so you know, from my perspective in the audience, really clear. So thank you. I will let you know if anything comes up.
Thank you. Mm-hmm. So let's go ahead and start from the beginning of computer science. We could represent pretty much all of computer science with a simple black box model. Inputs get passed in, something happens to those inputs inside of the black box, and relevant outputs get passed out. Now, with a show of reactions, who is familiar with binary? And I can't see the reactions, though. Oh, there's Enzo.
So it looks like we have.
Yeah, so
a few.
So a few people. Mm-hmm. So yeah, so I'll go over this. So binary is the way that computers take input. You've probably seen it in movies before with like zeros and ones streaking across the screen, and it's in base 2. So our number system is in base 10, which is much more convenient because our ones digit is the digit times 10 to the 0th power, which is just 1. Our tens digit is just the digit times 10 to the 1st power, which is 10, etc. Which it's very, very easy to remember. So binary is actually almost just as easy, except you replace 10 with 2. So base 2 will multiply the ones digit by 2 to the 0th power. the tens digit by 2 to the first power, etc. So the way computers represent binary, I've seen this in quite a lot of ways. They used to represent it with light bulbs, like with bulbs, but now we do it with these tiny switches called transistors, and they can be switched on or off, on representing 1 and off representing 0. And here's how you would represent a number like 13 in binary. So you first need to think of the powers of 2, starting from 2 to the 0th power, which is 1. So we have 1, 2, 4, 8, 16. So we know that 16 can't be it because it's more than 13. So we have to drop down to 8. We'll need 8 to make 13, and then 4, and then 1. So we can represent 13 as 1101. And just to recap again, you can, here, let me get my mouse out. This 1 is 1 times 2 to the 0th power, which is 1. This 1 is times, I'll get to Stephen's question in a second. This 1 is 1 times 2 to the first power. So right now we have 1. Yeah, so right now we have 1 plus 2. So then here we have 4. And we're not going to do anything there. And we're going to have it as 8. So, let me get to Stephen's question real quick. So, do computers have to use binary, or can they use base 10, hexadecimal, etc.? Yes. So, the way computers interpret binary is so basically hexadecimal numbers get translated to binary for the computer. But I think Stephen's asking this because he's really involved in graphic design and marketing. He helps me with a lot of that stuff. And hexadecimals are frequently used in like web development and other things like that. So what happens is they get translated to binary. So hexadecimal, for everyone who doesn't know, is basically just like another type of it's like another numbering system instead of base 10. And it's funny because since we don't have like 11, 12, and we can't fit that in, we actually go into the letters for hexadecimal, where you go like A, B, C, D, E, F. So you have like that range of choices instead. So the way the computers interpret it is binary, but from our perspective, we can pass in whatever numbers we want. We could use base 10, we could use hexadecimal, as long as we make it clear to the computer what numbering system we're in. The computer will be able to interpret that number and convert it to binary. And I'll explain how that process works, how like it gets converted to binary in a sec. So let me quickly go back just to make sure everyone remembers how to do binary. So this digit's 1, this digit's 2, this digit's 4, this digit's 8. And then we could just go across the line like that. So now I'd like everybody to translate the number 9 for themselves into binary. And we'll see what we get. Also, I believe there's actually a mistake here. I think this is not, I think this one is 9 already. So we kind of gave away the answer there. So, no, it's not 9. Yeah, that would be 11, correct? Yeah. It's been a long day.
No worries about it. Binary is hard.
So, let's have everyone do 21. And we'll see what we get. And once you get it, start putting your answer in the chat.
All right.
See, a few people have said a few numbers in chat already. Yep. Looks like everybody's agreeing on the same number.
And everyone would be right there.
Yeah.
It's hard.
The math's too big brain for me right now.
Yes, this late in the afternoon on a Friday, I'm just happy people showed up.
Yeah, the good news is that that number is good, either small or large endian.
Yeah.
Yeah, because some computers, they number from left to right and some right to left.
Perfect. Yeah.
So
Yes.
depending upon which one it is, this one actually works both ways.
Yeah.
For sure. We put it into any computer, we'll get 21.
Yeah.
You know, the first time I did binary, this
Let's
is
see. Like, I don't know, like back when you were in college?
no, high school, 40
High
years
school.
ago.
40 years. Wow.
Yeah.
Yep, that's how long this has been. Yeah, I heard I was looking at like vintage computers and such, and man, those were pretty massive, a lot bigger than the transistors we have.
I never thought I would hear that term, a vintage computer. When I was your age, I don't even know if we had computers.
Every computer I've ever worked on is vintage. What's kind of interesting with this is, did you explain why they're ones and zeros?
Yeah.
Yes. Because like there's like two states they could be in, and then they could switch like on and off.
It's because of the hardware.
transistors.
Yeah.
Yeah, it's the hardware.
Yeah.
Yeah, on
That's
and
the way
off state.
Yeah, because that's the way because like the only input for a computer is electricity. So like the electrons, when they go in, they switch it off from 1 to 0. And we can actually get into quantum computing at some point if you want to talk about that too. Because it's really interesting because they've been starting to develop computers that actually work with qubits. And what qubits do is they also go in like the on-off state and such, but they could go at different angles. And the different angles gives a lot more possibilities for the number of states they could be in.
So they actually go from 2 to multi-state.
Yes.
Right.
And people can actually make like faux quantum computers that way by like representing these states in a way that's not actually through qubit technology, but just using a traditional computer to model what it would look like. But yeah, it's cool. I want to say like, yeah, I'm not sure what the maximum number of qubits we've gotten to yet, but it's very interesting. Like we could private an entire workshop on just storage.
I wish I had kept my Mylar tape for when we used to boot up computers, because it was 8 bits. Well, actually 7 bits plus parity. So you had to actually be able to read all this stuff all the time.
Yeah, I heard they used to do code like by like punching like holes into it like manually.
Well, that was it. Yeah, because basically this, we had 32 bits was big at the time. 8 bits was the maximum size for an instruction. So 1, 2, 3, you got 5 bits right there. You got 3 more. You'd use 7 for instructions and 1 for parity to make sure the bits all worked out. And so those 7 bits would indicate either a type of instruction the computer could understand. So you were limited to 255, well, actually less, 127 different types of instructions. And then the following data bits would have, data bytes for those bits would be used for data.
Yeah, we have moved slightly past that in the last couple of years.
Well, let's thank God. This is 1972.
Yeah, my dad was born then.
Exactly. I'm way too old, obviously.
But yeah, it's really incredible how.
But the point is,
changed.
this is like physics or chemistry. This doesn't change.
Yeah, for sure.
The underlying fundamentals stay the same.
Yeah, I mean they might change in 40 years from now, but we'll see what happens. We'll see what happens in quantum computing. Yeah, so let's return back to our black box model here. So and I'll get to your question at the end, Benjamin. So in the black box, which contains your code, there's actually another black box in there. And you might be asking, how is that possible? Because computers actually can't read your code without the help of a compiler. And Ray definitely knows about compilers. Back then, I remember it was a requirement for like most of the people I know who did programming to code their own compilers. So they're probably more familiar with that process. But you may be familiar with a compiler. You could run one using the terminal on Mac or the command prompt on Windows. And what compilers will do is they will read your code and convert it to binary for the computer to understand. And let's get to something more concrete. So, and Tanya, if you could help like pick somebody for this, how do you think that computers represent letters? And I'll once again check in with you all on how you think this should happen. So raise your hand if you want to answer.
Right, anyone? How should computers represent letters? What do you think?
I'll give it a shot. I know nothing about programming or coding, so this is total guess, but
Yeah, go for it.
based on what you said about binary, maybe there's some sort of binary system for the letters as well. Like each letter would be a combination of
Yes.
zeros and ones.
You are 100% on the button there, Enzo.
Yeah.
So yeah. So there's actually something called Ascii, or the American Standard Code for Information Interchange, that represents each letter of the alphabet with corresponding numbers. So it changes depending on what system you use, but in like the oldest version, 65 used to represent A and 66 used to represent B. But now we have other systems like Unicode that do sort of a better job, because when it comes to storage, one transistor is worth 1 bit, as Ray was talking about. ASCII goes from 0 to 255 or 256 possibilities, so it requires 8 bits per letter. 8 bits make 1 byte. So 1 letter in ASCII is equivalent to 1 byte. Unfortunately, the human language is a little bit more complicated than just 256 possibilities, especially if you want to represent even something like emojis, where we have more than 256. So now Unicode could even go up to like 16 bits sometimes per one, because we just need the more possibilities for it. And so now that you've seen how our computer interprets binary, this simple 0 to 255 number can actually be interpreted in wildly different ways. So following the same logic, how do you think that color is represented in binary? And if you've worked in graphic design, you probably know the answer to this one. And I can't see the people, so once again, Tanya, please pick somebody for me.
Sounds good. So it looks, Philippe, would you like to go ahead and answer this, Philippe?
Oh yeah, I'm sorry, I have some noise here, but answering to Benjamin, actually, if you make use of some design partners and architectural partners and the styles, it helps you to build a good program that works very good. So all the 3 together, I'd say is the answer to your question.
The 3 together?
Yes, yes. Actually, they say that you start as a developer, then you become a designer, and then software architecture, and some levels that you have.
Yeah, I think because of the study, you might have misinterpreted my question, even though you did do a great job of helping answer Benjamin's. I was asking, how do you think color is represented in binary?
Oh, well, he meant the 3 codes. You see,
Oh, yeah,
YGB.
he meant the 3
see?
codes.
He meant the 3 codes when
Okay,
he said
sorry.
the 3, YGB, right?
Sorry, I heard the architecture.
I know, I'm just
got distracted
joking,
by that part.
but that's, but
Yeah.
you see how that works. It is that actually, right?
Oh yeah, it is, Ray. So yeah, so like the basic form of color, as Ray helped, it was basically you take that exact same 0 to 255 per pixel value and you assign it to like red, green, or blue, like Ray just said. And that's why binary is so fascinating, because it could hold many different data types by however the computer is interpreting it. So like the word hey in ASCII, like what an exciting word, is like this mauvish color. If you actually look at it, it's kind of like a grayish purple. And binary can be used to store attributes of many different files. So from images, which is like a collection of colored pixels, to videos, which is like a collection of images, everything on your computer helps communicate through binary. Are these like color codes? Yes, so it's similar to color codes, except you convert hexadecimal to binary. So it's pretty much the same. It's pretty much a very similar process. So and here's what it looks like. This is from the Harvard CS50 course, which is like an introduction to computer science course. And as you see, ta-da, just three numbers, like Ray said. Now, let me pause my screen real quick. So now you might be thinking, hey, Brett, this is nice and all, but I came here to learn some code. So yeah, we certainly can get into the code. Now, I can help people install the IDE or the integrated development editor that I will show on the screen, but it's a multi-gigabyte download, so I have an alternative for that in the meantime. Let me quickly reshare my screen. Here we go. Everyone should see my blank development editor, and if everyone checks the chat, and this is actually done, this Python editor is actually done with PHP. So the backend language we're just discussing. So if everyone clicks on this link, you should be greeted by a website that has two sides. The left side will contain like the coding area that you can write in, and the right side will contain what like comes out of it. And so I'll give everyone a sec to get that set up. And in the meantime, I'll discuss, if you want to go back to that box model for the final time, you could think of the black box as a compiler. And the compiler is going to translate the code you write today into binary. So let's get started. Feels good to finally be in the developer editor again. So today I thought what we could do is build a basic accounting app. Not like quite an accounting app, but more of like a bank checker app.
Hey, Brett,
So-
can you change the color scheme a little bit? It's a little bit hard to read on our screen with the black on black. That it's a much better. Thank you.
There we go. So yeah, I forgot how tiny my screen is. So if you see anything that I write that's followed by a pound symbol, all that means is it's a comment, so it's not going to actually have any influence on the program that we write. And today we'll be coding something in Python, which is the language that my team's app, Pygen, helps teach kids. So let's get started. So to start out, we want to like have a place where we could store things, because storing things is very important to an application. Without data, we really don't have anything for our users. So let's create like a fictional account for somebody. And we'll get started with a variable. So the first thing that you have to do when you declare a variable is come up with a name. And this name should start with a lowercase letter. And it could be like something like ID. So the next thing you want to do is add an assignment operator. And what the assignment operator will do, like I know in math it's different, but what this does is it says whatever this is, it's going to give the data address for whatever string we put here, or it's just going to assign the primitive type of a number if we want to do that. So let's go ahead and do that. So say we want to do an ID of 1, because this is our first person. And oh, make sure you clear out like the other text that they put in on the left side as well in the web browser. So yeah, so let's start by printing this ID. And when I was talking about the black box, I was talking about functions and how they could help you with your code. So this is your first example of a function in Python. it is print. And just spell print like this. What you want to do is you want to open the parentheses like this next. And then, so basically what's going to happen is this is where the input goes in the black box. This is the first part. And what you're going to want to do is pass it the thing you want to print, which is your ID. So you could copy your ID and put it in here. Let's go ahead and save that. So on your editor, what you should see is an execute button that's located at like, should be around like the top left of your page. So try clicking, I'm going to click this play button, but everybody else click the execute button. And let's go. And what you should see in your terminal, which is located on the right side of your page, you should see 1. And everyone give me a reaction if you see that.
I forgot to clear out hello world, and if you also forgot to clear out hello world, it'll also say hello world on your output.
Yes. If you didn't clear out hello world, we're gonna say hi first. And yeah, let's go ahead and yeah. So we have our printed ID out here. So let's just get this out of the way. Like just move this like the bottom, like over here. And if at any point someone gets lost, feel free to just pop it, just unmute yourself and just tell me something went wrong. Because don't want to get lost in this. It takes a bit of time to get back on track. So we're going to make a new variable, and this time we're going to make it a string. So what a string is like a collection of characters. And you just start it off like a normal variable. You put the name, you have the assignment you have the assignment operator here. And what you do on the right is type in like an email address. So this is one of the email addresses I have. So I'm going to put this right here. Don't worry, the site isn't saving any of this. It's not saving your email, so it's perfectly safe to put in. And I think you know the drill at this point. We're going to call the print function again, and then call email right here. And as you see in the output, we're going to get, well, exactly what we had here. So as we're going to keep building this app, we need something with decimals though. The issue with integers is they can't have decimals on it. So the way we declare a decimal in Python is actually extremely convenient because you don't need to do anything special. All you need to do is define your number with a decimal point. So it could be like 12.0 or like 18.0 or 18.52. Any of those will work. You could just give yourself a weird amount of cents if you want.
3.1415.
Yeah, that yeah, you'd have to like carve up a bit of a penny to get that amount. If you go ahead and run it, you'll see, look, the decimal place is here. That means you have created a double. And a double is what Python uses to represent decimals. So next, we're going to go to another data type. And this data type is true or false. And it's called a Boolean. It's a Boolean. And basically, it can hold true or false values. So we want to see if this user is a premium user. Now, I never buy premium for anything. I just use the free trials. So I'm going to put false. And go ahead and see what happens when you print premium itself. You should be continuing to get these consistent values. You might be asking, why are we doing all this? And trust me, we're going to get there. And the last thing I want to show you is a list data type. Lists are probably one of my favorite things in Python because you can actually store more than one thing in there. So let's add a stores variable where you could put like all your favorite stores. So here I'm going to put Yogurtland, Target, and let's put Amazon too. And the way this works is you have square brackets this time instead of curly brackets or rounded brackets. So these square brackets are located, because if you never use them, they're underneath the negative sign and the plus sign on your keyboard. Continue to put, and as you see around this text, make sure that you put quotations around it because that's the way you define a string. And you want to make sure these are closed up or you're going to get errors. As each of these is one string in the list, and they're separated by these commas here. I'm actually going to paste this into the chat. Yeah, Steve, it is weird because like I started out with C, and C uses printf. So it was a very strange transition for me. It's so weird because it also puts the \n into as well, which kicks it down another line automatically. So like when I did this the first time, I expected them all to be like on the same line, and they weren't. It was kind of scary. I'm just gonna put this in here in case anyone's having difficulty. Yes, Sarah, I 100% agree with you about that. And yeah, it's so funny to see everyone who's done programming languages with like other syntax, because like Python is extremely like kind of like on the more cutting edge side of things when it comes to stuff like syntax. So yeah, the no semicolons, the no having to predefine something as a double, it's all kind of weird sometimes. And we're actually gonna print out each individual element of stores. So let's see, Ray, do you know how a list, or if you did C or Java, an array orders things? Oh, I believe you're muted.
You're still muted, Ray.
I was just saying, you can't read my lips. So I'm not familiar with PHP, but what's kind of interesting with this is that would it be stores dot one, or how would you get to the first variable in that?
Yeah, so
That would be my guess.
Yeah, so stores.1 is actually very close. Also, we're working in Python, not PHP.
Oh, sorry, Python.
But sorry, I said PHP a bunch of times, probably mixed it up. But like what you described is the notation for a class. So you actually did, but the thing is you got things right in the future. So that's if it would belong to a class. So that is a very good guess. So how this works is to access one of these, and I'll put it in a print statement again, but you type in the name of the list and you put in your square brackets once again. And so what number do you think we should put in to get this one?
1.
Do we have any, so as this is 1, do we have any other guesses?
0.
We have 0 too from Philippe.
I'm gonna go with 1 as well.
Steve's gonna go with 1. Ray, what do you think?
I go with 1. 0's a very special case. You gotta be really careful if you're gonna do a list with a 0.
Yeah. So Felipe is actually correct on this one. So you see, if you run stores 1, you get Target and not Yogurtland. So the way lists in Python work, and it's like this in Java as well, they start out with a 0 element, and then a 1 element, and then a 2 element. So all of the lists in Python are 0 index. So they actually start with 0 first.
And what I'd say is be awfully careful when you go translate to any other language, because that's not typical.
Well, it is typical in languages like Java and Swift and C and Python, which are mostly like the common languages now. But I 100% understand like the.
What happens is when you go into data structures, it totally screws this. So that's what you have to be really cautious about, like when you're doing data sets, right? And you're actually using SQL or stuff like that. Yeah, okay. Just be careful.
Oh yeah. If you, So what Ray's talking about, for people who don't know, SQL is another one of these great backend languages, but you do have to be extremely careful when you use indexes like these. But in most of the modern data science worlds, 0 is actually perfectly fine to use. It's just when you translate back to these older languages, you do have to be very careful about it because they don't come with as much safeguards as the modern languages. So so we have 0, 1, and 2. So 0 is going to print out. All right, let me get this down here again. Get rid of the, try to slide the problems one over a bit more. So as you see, we get Yogurtland first, then we get Target, and then we get Amazon. And you might be thinking, this seems incredibly impractical. What if I'm like a huge shopper and I have 100 stores in here? Well, we do have a solution for you, and it's in the form of a loop. So so just remember what this looks like, but I'm gonna get rid of it for now. And this is one very cool thing about Python, because this solution will work no matter what the size of your list is. So here's the more practical way. You'll type 4 and then store in stores and print store. Don't forget the colon over here. So and this is pretty cool. So does anyone think they know what this does? You could give me a low reaction, or just unmute yourself.
Does it say store? Oh my gosh. Oh my! I gotta recall my C knowledge and remember functions. I don't remember how to do any of this stuff. It's been like over a decade.
Well, unfortunately, C is not gonna help because this is not in C.
Oh man, I have no idea what's going on.
Yeah, so it looks like something that could be from C, but it must look like a fever dream to you because it doesn't exist.
Yeah, it's like C, but like slightly off. And
it's slightly off, right? Exactly.
Yeah. So that's actually really cool. So basically, it's it's doing an implicit run through your entire list by associating store with every part in stores, every particle of the stores during the for. It automatically executes this without having to indicate what store is, huh? This is pretty cool.
Yeah, that's 100% it.
That is crazy right there.
It's wild. All right. Also, I'm sorry I didn't get to call on you, Sarah, but I'm 100% sure you knew, given your past comment. You sound very experienced. But yeah, is that unbelievable, Ray?
Yeah, that's
the amount of programming has changed.
You don't even have to tell it what store is.
You don't even have to tell. This could be anything. It could be an object for all you care. It doesn't even have to be a string. It's it could be a custom class. And something that's even crazier about this, and this might like completely blow your mind. You could also add like a number in here and it'll still work. You could be playing around with types and it'll still work.
Wow.
It's crazy. It's absolutely crazy.
Well, that makes, it's simplistic. It just, whatever yeah. So if you do that, will it actually print a 28 out?
Yep.
Wow.
That is nuts.
It's crazy. It's really crazy.
That is, you guys have no idea how insane that is, because God forbid you do that in any other programming language, you'll get all kinds of errors.
If you did that back when so my first language was actually Objective-C, like not even C, like the really bad version of C from like 1970. So yeah, I ran into those errors all the time. So I switched over to Python. I didn't think this was real.
Wow.
Wow.
Why didn't we have this growing up?
Yep.
I know, right? That's why I'm saying programming is getting so much more simple for kids to learn, because like whether you don't have to worry about all this like type matching or like pointers or that kind of stuff, it's so much easier.
So why did you have to use the quotes for the yogurt land?
Because basically a string. Yeah, so the way you define a string, because like let's think about it like this. You define an integer as a number with no decimal point. You define a double as a number with a decimal point. So the way that the compiler recognizes a string is when there are these quotation points around it.
So the question, here's what's interesting. When you're printing out 28, is it printing it out as a string, or is that as a number?
It's printing it out as a number.
So then basically, if you go back to your for loop, this is wild. You're telling me I could do this, and inside of that, I could do something like store times 2 or something, and it would take that 28 and multiply it.
Yes, it would.
That's crazy.
Oh my God.
I'm mousing over it here to show you. You can clearly see they are separate integers and strings. It's not being it's not being type swap beforehand.
Yeah. Wow.
It's crazy. You do this in another programming language and you'd have a crash on your hands.
You'd have something. I love it. Thank you.
No problem.
Oh my God.
Yep, and we're heading to the very last thing that I wanted to show everybody, and I know we're starting to push it on time, so I'll wrap it up real quick. So you might be thinking like, oh, this is nice and all that, but like, what if I want to print all of it out in like one string? So I was like, this is just too much. It's too much. It's not readable for anybody. So let's just delete all that, delete all your old prints, and what we can do instead is something called concatenation. And what concatenation will do is basically you could add strings together to form like one big string. So let me just show you how that works. And you want to be careful with your quotations at this point. So you have print, you put in your quotation marks here. You want to put in user number. What we're going to do is a plus. And then here's when we're going to add the next string. But you might be saying, Brett, it's a number that we have next. It's an integer. How can we add a string and a number together? And you can't. Unfortunately, Python won't let you do that because there's too many risks to that. But what we can do is typecast it. So what typecasting will do is it'll turn the integer into a string. All we have to do is type this function, str, here, and then type in ID. And I will pause with this and let everybody run their code one more time to make sure it works. And as you see, I get user number 1. And just throw up a reaction in the chat when you get that. Nice, I'm seeing some reactions. Enzo got it.
Why is Python so much easier to use than C?
I know, right? It's like the whole like barrier to learn is so much easier with Python than with like the languages we started out with. It's really remarkable.
You know, I just want to make a quick comment. Brett, I feel so smart because my thing is working. And I have a great team.
Same.
Thanks, Enzo and Steven. It's great to hear. And let's make it even more complicated now. So let's make sure you add another plus here and add another string. And remember, you define a string by having these quotation marks here. What you're going to want to do, add a space in between so it doesn't get all messed up. Type in has a balance of $. Don't add a space here. And then let me stretch it out a little bit so people could see. What you're going to want to do here is, and if I'm actually going to leave it here really quick and see if you could add balance in yourself to here. When someone's got it, just put a reaction in, and then I will give the answer to everybody else. If I miss your reaction because I'm really bad at spotting them, just unmute.
I don't think we have any in there yet.
One thing I realized today is I didn't realize so many direct student founders had coding knowledge.
I
don't talk about it.
Yeah. Yes. Who asked?
Yeah, I had a question. So like in Java, you can print things just without using, like, you just do print instead of print line.
Yes.
So is there a difference in Python as well? Or do you have to like concatenate to actually put things on the same line?
There's a couple different ways you could actually get it in, because I know in Java you have a printf too, I believe, where you could format things a lot quicker and easier. With Python, we actually do have something too like that. But the reason why I didn't put it in today's lesson is because it goes a bit beyond the scope of the lesson.
Yeah, you can do this in C#.
Yeah.
I'm sorry.
Concatenation is pretty ubiquitous.
Yeah, I kind of lost what you want there.
Yes.
What did you want us to do?
Yeah. So here, because we're running low on time, I'll put it in. So what we're gonna do is, you see you have the balance variable up here, and it follows, it follows the same technique where you do str, you put this in, and then you type in balance.
No, I missed that.
Yeah, that's fine. One thing that you'll do if you end up doing more programming in the future, you will always remember the names of your variables, because you have to go back to them again, again, again. And let me do this and make sure it runs properly, and it does.
Oh no, I got an invalid syntax.
Uh-oh. Yeah, be sure to check your be sure to make sure everything is contained in itself properly.
And the spaces matter, right?
Yeah, the spaces matter, but for how, yeah, if you want
Not
the correct
inside
output,
the brackets. I mean, not inside the quotes.
yeah,
No.
in the quotes, it'll make it look nicer. That's all. But it won't crash your program if you mess it up inside the quotes.
Oh, I still got a syntax error. What did I do wrong?
And people are having difficulties with it because I will paste it in the chat so people can put it in themselves.
Oh, I forgot. I know what I did wrong. I left out the plus.
Yep, that'll do it.
The last plus. Yeah, because that's the concatenator.
Yeah.
That's actually the same as in C#. The concatenator.
Yeah. Same in JavaScript. It's in the same as Swift. Same as Objective-C. So this is one thing that stayed the same, at least. Except, as Sarah mentioned, there's a ton of different ways you could actually do this. We're just picking a simple way right now. And yeah, so once everyone's got that going, the very last thing we will do today is I'm going to show everyone why it's called object-oriented programming and not just programming. So, and I'll be sure to I'll actually include this file. Let's see. Tanya, can I give you the can I send you this like the text of this file later in like a Google Doc or something, so you can send it to people?
Absolutely.
Because I might just need to speed.
Well, thank you for the site. I actually signed up for the site.
Yeah. You know,
yeah, no problem.
As long as everybody signed up with their use Eventbrite to sign in for this, I'll just download everybody's emails and send them what you send me.
Yes.
So I actually signed up, and so I could save this project.
Yeah.
Yeah. And if anyone wants to save their project, definitely go ahead and make an account.
Yep.
That's awesome.
Yep.
Yeah,
And if you signed up on Eventbrite, the Eventbrite should still be up. That's the only way we can get your email. So please make sure to go sign up on Eventbrite.
Yep.
So my coding is a bit rusty from time to time, but I can read code. So
Yeah. Do you have like you're like a polyglot. It's like somebody could recognize the language, but they don't quite get the nuances of it yet. For like all of them.
So the biggest problem I'm having with, because I've skipped like a dozen years, is some of the class container capabilities where I can show you some C coding that we're doing inside of Unity, and the capability for monocode to be able to just take and call a routine within a routine, and pass variables and know exactly what you're getting to and from is insane. I mean, I could show you an example of it. It's just, you guys want to see. I mean, I'm sure he's got code too. So it's, go ahead. I want to show you this though, because this is the stuff that got me going the other day.
Coders love their code,
Yeah.
Well, this isn't, well.
Ray, could you wait 5 minutes
Yeah,
until
no, go for it.
I finish it, and then I'll definitely stick around to talk to you about it at the end.
Yeah.
So.
Oh, no, I don't want to hold you up. Go for it.
Oh no! I just want to make sure people can make it to dinner if they have that. So
dinner? What's that?
for coders, it's at your desk. So so here's how you make an object. So I might be thinking like, oh, strings are cool, but how do I make like an object of my own? And strings are kind of their own special thing. Like you can't. But if you want to make a basic object, what you could do is class space user. You could indent in here, and what you want to type in. And this is why I was going to have Tanya do it, because it's kind of hard. It's def space underscore space underscore underscore init underscore underscore parentheses self ID email balance premium stores colon. So what you're going to want to do is call self, which is the object itself that you're going to make. Self.id equals ID, self.email equals email, self.balance equals balance, self.premium equals premium, and self.stores equals stores. And this is how you make a constructor for a object.
Right.
And I'll give everyone just a sec to catch up there.
Can you explain what the self does again? Why self needs to be in there?
Yeah, and I remember. Yeah, thank you, Steven, for putting that into chat. So basically, what self does is when you initialize the object, you pass in these inputs to it. But what happens is you're making like a new type. So what these variables only exist in here. So what you're going to want instead is when you create this new variable, it's going to call itself. It's going to say my ID is the ID you passed in. My email is the email you passed in. Because otherwise, this is just existing in its own input. So you're moving it from here to the object itself when you create it.
Basically, you're making a copy of it in its own array.
Yep. Maybe not necessarily an array, but definitely tied to its own memory address.
So what? Yeah, I'm sorry. This is again me having lost years, but basically, for me, an array is anything that's multiple instances of things in it. So in this case, this is actually what you were calling a constructor for this object, right?
Yeah.
Yeah.
And like and like if you've worked with like Java and stuff before, you've obviously come across array lists and such. And the last thing I want to show everybody is like, okay, this is cool and all, but how do we turn this into this? And it's pretty easy. So everyone type in user equals, and it doesn't need to be called user. It could be literally called whatever you want, but I like to call it user just for simplicity. And you want to say capital U, SER, has to be capital, put the parentheses around it. For self, don't put in anything. That's not necessary. What you're going to want to do is put in the ID, which is 1. For the email, you're going to copy paste the value you put here and put it here. For the balance, you're going to copy paste the value you put here. For the premium, you want to put it in here. And for the stores, you want to put it in here. And that's going to declare your new user. And this is what Ray was alluding to earlier. If you copy paste this print statement you made, and let me try to widen it a little bit, you could actually call now. And if you go to here, sure, I have like a bunch of other stuff. Maybe I'll make a part 2 of this so we can get to all the other stuff.
Yeah.
So
Cool.
there's just so much you could cover with this. What you're gonna want to do is type in user.id and type in user.balance. And if everything goes right, what it should do is print out the values that you put in here. And that way you didn't have to go through all this mess up here. And as you see, you get the exact same output for both and so much less code.
Yeah.
And what's nice is this user could be reused over and over again. We could make so many different users. Every time a user signs up, new user, without having to type in all this. Because otherwise, what would we do? It'd be like ID 2 equals 1, email 2 equals. This is so much better.
So it basically boils it all down to a single line rather than a block of text.
Yep. And that's the wonder of object-oriented programming instead of just programming.
Wow.
So, yep. And I'll be sure to get this in a Google document for Tanya and send it to everybody. So if you miss something at some point, yeah, we could get that to you.
And I was going to say, Brett, like seriously, if you want to do another one of these, this is really cool. I love it. I mean, I'm sure we would all love to come back if you want to. I know we're getting close to the
yeah, I think having the programming side up and doing it alongside you really helps.
Thanks, Stephen.
Yeah.
And yeah, I just like to thank everybody for spending their Friday night with me because yeah, most people are partying. I'm doing coding. So have fun with that.
Hey, we're all here with you. So
yep, we're here for a reason.
Yeah, it's kind of, yeah. Actually, I put in false. I made it all caps on the user string. And it was funny because it barfed on that.
Yep, it's very specific with what it wants for that. So at least that thing didn't change, right?
That's right.
So we'll go ahead and wrap it up here. If I'll let everybody know when the video is ready, when that comes out, we'll also send you, we'll go ahead and send you what Brett sends to me. And I think we can stop the recording now.
Yep. Add me on LinkedIn, y'all.